Welcome to chapter 20, which is the big time deals example. This is the third example we've done. It's by far the biggest example we've done so far. It's significantly bigger than the last one. So let's walk through it. We're going to use, the exact same process we've used for the first two. Even though this is more complicated, you just got to work the process, work through those steps. So number one, understand your application. Number two, build your ERD, that entity relationship diagram, so you know your objects, you know how they relate to each other. Number three, define your access patterns, know what you're going to be creating, reading, updating, etc. And then finally, get in and design your table, design your primary keys and those secondary indexes to handle your patterns. So let's start and understand our application, see what we're building here. We are building a deals aggregation site. So you can think of something like slickdeals.net or other ones out there. It's going to be a totally mobile first application. So I'm going to show some screens on a mobile phone of what it looks like. Here's that home page, that front page that you're going to see when you open up our deals app. You can see at the top, it's got some featured deals across the top. There's going to be a limited number of, 5 or 10 deals that our internal editors have set as featured deals. We also have different categories, and those are 8 static categories like food and drink, bathroom, jewelry, sports. Those will not change. Those will be the same 8 categories all the time. And then it's just going to have latest deals, which is just going to be an infinite scroll of the most recent deals that we've seen. If you look on the bottom there are a couple different buttons you can click to get to different pages. That next button is the brands page. So let's click at that. It's just going to be a list of every single brand we have in our application. And this will allow you, if you have some favorite brands, you can go out and find those there. Right now, we have about 100 brands in our application, and it's not too frequent that we add new brands. So maybe 1 or 2 a week or a month, but not, thousands and thousands or millions of brands. If you click onto one of those brand pages, this is what you're going to see. This is the brand page for Apple. It's going to have the latest deals for Apple. It's also going to have the number of likes and the number of watchers for that brand. So users can come in, they can like a brand, they can also watch a brand, and we'll talk about the implications of that in a bit. Likewise, there's also the categories page. This is the tech categories page. Very similar to the brand page that we just saw. It's got likes, it has watchers, it has the latest deals. The one thing it does have in addition to that is that featured deals across the top, where some internal editors in our application will set the featured deals for this category. We don't have that for brands. If you click on a particular deal, this is what you'll see. So here's a MacBook Pro deal. It's got the image, it's got some details about it, some features, it's got the price. It's also got, get this deal, but also links out to the brand or category if you want to. Another page we have is what we call the editor's choice page. So this might be deals that aren't the most recent deals, but they are ones that we think are pretty good and pretty popular. Again, that's going to be 5, 10, maybe 20 at most. And these are all going to be set by our internal editors. Finally, the last view we have is sort of a user settings page where a user can see, their profile picture, their email, all different things like that, as well as their inbox, which are just going to be alerts on different deals. We'll have a few different ways to alert people of new deals. First of all, there's certain deals that we want to push out to all users, and we call that a hot new deal item. We'll push it out to everyone. Second, if a user watches a brand or a category, whenever there's a new deal in that brand or in that category, we'll send them a message for that, and they can get that. Also, if you look at that inbox, you can see that they can see all messages or just unread messages. So there's going to be that sort of filter on it as well. So again, let's just understand what we have here. We have a deals aggregation site. The big core entities there are going to be deals, brands, and categories. So for each deal, it belongs to a particular brand. It also has a particular category, and you can browse that way. We also have featured deals on a few different things. So, that front page is going to have featured deals. Categories is going to have featured deals. And then we'll also have some special pages like that editor's choice page. Additionally, there'll be users in there, and users can like or watch either brands or categories. And if they like it, they're just sort of signifying they like that sort of thing. But if they watch it, then they'll get messages anytime a new deal comes in that brand or in that category. Finally, we have that message entity where users will get messages into their inbox. So now that we know our application a little bit, let's get in and build our ERD, our entity relationship diagram. This is what we have here. Sometimes your ERD and how it applies to your application will change as you get in and model, but this is what we started with. Let's start over in the bottom left-hand side where we have that user entity. You can see there's a has relationship with messages where a user can have multiple messages, but each message will belong to one user. A user also has a meta-to-meta relationship with categories and with brands via either that like relationship or that watch relationship. So it can have both types of relationship with either a category or with a brand. In the bottom right there, you see that deal entity, and you can see that a deal is related to both a brand and a category. So there's a one-to-many relationship between categories and deals, and a one-to-many relationship between brands and deals, where a deal will belong to a particular brand or category, but each brand will have multiple deals and each category will have multiple deals. Finally, in the top right there, we mentioned that some deals are featured deals, so we might have some sort of special entity or relationship there. So I put that on there. We might not model that out. We'll see what that looks like. And then finally, at the very top, we have that pages entity, the front page, the editor's choice page, and those pages might have some featured deals on them. So we've got that mapped out. We'll see what that looks like as we start to actually model it. So when we look at this, we have sort of seven entities listed, those core entities around deals, which would be deals, brands, and categories. Then we also have sort of those collections or meta categories like featured deals and pages. And then finally, we have our users and our messages. We also have 10 relationships in our ERD. 5 of those are one-to-many. 4 of those are many-to-many, and those are the likes and watches between, users and brands and users and categories. And then finally, there's that one-to-one where a deal might be a featured deal. So maybe there's a one-to-one relationship there. If we look at our entity chart, we've just split out those 7 entities. Because it's pretty complex, we're probably going to use a composite primary key. So we've got that split out into PK and SK here, but we'll see. Let's get in and define our access patterns now. We really have a lot, so I'm going to break them up into different groups. The first one is just be around those core deal entities, so creating those entities. So we have create deal, create brand, create category. All of this is going to be happening in a sort of internal CMS for our editors. This isn't going to be a user-facing action at all because a user doesn't create a deal. Only our internal editors do that. Likewise, we also have this set featured deals where on a few different types of pages, we want to say, hey, these are the featured deals that are going on right now. So we have those for the front page, for each category page, and then for that editor's choice page. Again, that's going to be all internal. Our internal CMS, our internal users are going to be setting those via that CMS. Once we have those sort of creation flows in our internal CMS, then we have our user-facing flows around fetching those deals. So a few of them that go together, we for that front page, we want to fetch the featured deals and the latest deals to put on the front page. We also want to fetch the featured deals and all the latest deals for a particular category. Next, we want to fetch the featured deals for the editor's choice page. And then finally, we want to fetch the latest deals for a brand, but we don't do featured deals for a brand because there are just too many brands. We don't want to sort of get involved in that. Whereas with categories, we only have 8 categories. We can do that. 2 more fetch actions we have. We want to fetch all the brands. Remember, we have that brands list page. So we want to be able to show all the brands. That's kind of a tricky access pattern, but we can show how that'll work. And then finally, fetch a deal when we want to get an individual deal if someone's clicked on something and wants to get more information there. All right, so the next group of access patterns are all around users and how users interact with these deal entities. So, we have this create user. When a new user signs up in our application, we'll create that user. And then we have these like and watch interactions that we have where a user can like or watch a brand or like or watch a category. Finally, the last set of access patterns we have is around messages, where a user has this inbox and they can view their messages. They might get messages. So 2 read-based access patterns with messages. Number 1, view all the messages for the user. And then number 2, view the unread messages for the user. Additionally, we have this, send hot new deal message to all users where at times editors in our application might say, hey, there's enough, this is an interesting enough deal that we want to blast out to all users, even if they aren't watching the particular brand. So we'll do that. And then we also have those watch-based messages where if you're watching a brand or if you're watching a category, every time a new deal comes into that brand or category, you'll get a message and get alerted of that. So that's 22 different access patterns we're going to handle here, and we're going to do it all in a single table. We're going to apply some of those patterns we've seen in earlier chapters, especially those strategies chapters where we can see how you model these relationships or handle special filtering or sorting needs. So let's get in. Let's design our primary key and indexes. First thing we always need to decide, are we going to do a simple or composite primary key? That's a pretty easy choice here. You're usually going to lean towards that composite primary key, but especially when you have these very complex access patterns that have fetch many type relationships, we're going to do that here. Next thing you want to look at and note down is, do I have any interesting requirements across my application? I think we have a few here. Number one, we have a lot of time-based access patterns to where, on the front page, you're fetching the latest deals overall. You're doing something similar for the category page, the brand page. And that can be kind of tricky for a few reasons. Number one, you have to put a lot of items into maybe one partition, which can mean that partition is going to get pretty big over time. So you think about how to split that up to control the size of it, but also just to control the speed of it, where those most recent, 25, 50, 100 items are going to be getting read a lot. And how can you release some of that load on what's going on there. Second interesting requirement is a deal is going to be viewed in multiple different contexts. So this goes with that time-based access pattern, but we can see a deal in the most recent deals overall, but also the most recent deals for a brand and for a category. So we need to make sure we can handle it in all those different contexts. Another thing that's interesting that we haven't really seen before is there are really two perspectives on this application. There are the users who are actually surfing those deals, reading their messages, things like that. But then there are the editors who work for our team and are interacting through some sort of internal CMS to do things like create new deals, create new brands, set featured deals, things like that. So keeping both of those in mind. And then finally, the last interesting thing we have is we have a few different fetch all entities of type X access pattern. That comes up in two different ways. Number one, on that brands overview page, we have a one where we say, give us all the brands we have in our application. Also, when we want to send a message to all the users, if it's a particularly hot new deal, we'll do that, which means we need to fetch all the users in our application. Those can be pretty tricky in DynamoDB to get all the users of a particular type, but we're going to show how to handle that in actually two different ways here. So let's get started modeling now that we know our access patterns. It can be tricky to figure out which entity you want to get started with. I recommend going with something core, and I think the deal entity is pretty core here, particularly because we're going to see it in a few different contexts. We're going to see it overall. We're going to see it within the category, within a brand. So I think we're going to model that one out. A couple different interesting things here we have with the deal entity. We have a few different fetch most recent patterns. So like I said, we're going to look for it overall, but also the most recent within a category, in a brand. And then because of that, it's the subject of two relationships, those categories and those brands. We're going to use, for that most recent pattern, we're going to use this similar pattern for sort of all three of those, where we have the fetch most recent overall, but also fetch most recent with a category and a brand. So let's see what that looks like here. First of all, in our base table, we're not going to model any of those fetch most recent. We're just going to handle the deal itself. So what we have here for our partition key and our short key is a pattern of deal, hash, and deal ID, where that deal ID is going to be one of those KSU IDs that we've talked about before, used before. Just a reminder, the KSU ID gives you uniqueness, gives you unique ID generation, but it also is chronologically sortable, which is going to be great for us here in a second. So then when we look at how to handle that fetch most recent pattern, let's start with fetch most recent overall. And one thing, that I'm worried about is that partition getting too big. If we put all the deals that have ever happened into a single partition over time so that we can order by timestamp, that's going to be a really large partition. So I'm worried about that. So one thing we're going to do is split up that secondary index partition according to a timestamp. But we can't split it up according to just the timestamp itself, because we want to put all these items in the same item collection, but it's unlikely that two will have the exact same timestamp, or you'll have very few with the same timestamp. So we want to get some level of granularity, but not all the way. So what we're going to do is going to use called a truncated timestamp pattern. If you look here, we've got this GSI1 PK, GSI1 SK, where the pattern is going to be for that PK, it's going to be deals, hash, and this truncated timestamp, and then the SK is going to be deal, hash, and then that deal ID. So let's talk about what I mean by a truncated timestamp. And what we're going to do is take a timestamp that's pretty specific all the way down to a second and truncate it to something less granular, either a day or a week or a month. So I've got a couple examples here. On the left is that very specific timestamp, and then on the right is that timestamp truncated down to a day. So if you look at that first timestamp, this is for January 13th. It's at 2:35 in the morning. But on the right, we've truncated it down so it just says January 13th, which means all the deals that were created on January 13th are going to be together in the same partition key, same item collection. Likewise, those next two are both for January 30th. One is for 1:42 in the afternoon. One is for a little afternoon there. But when they get truncated down, they're both for January 30th. Which is going to be great. And that's what we have here. So we've got that outlined. If we take a look at our secondary index, we get this here, and we can see that all the deals that are in January 30th are going to be in that same item collection, and we can run a query against that, but get the most recent. And that allows us to get some grouping, get some sorting functionality while not overloading one partition with too many values. Let's see what this looks like in code. And the structure I have here is going to be very similar to the e-commerce structure. So if you've done that, it's similar, but just to run through this again, I like to make a directory of what I call entities, which has my different items and entities that are going to be in my table. Here is the module for the deals entity where I have this class. It has a constructor, and then it's also going to generate things like the primary key, any GSI values, and it also knows how to serialize that to a DynamoDB item. Finally, it also knows how to deserialize a DynamoDB item back into an application object with this deal from item method we have here. So we have that object and that knows how to serialize itself, and also a way to deserialize it. Finally, I have this handler directory, which has my different HTTP endpoints I want to handle here. These are Lambda functions. Basically what I'm doing is defining a JSON schema of what I want to come in. So anytime someone creates a deal, I want the title, I want a link, I want a price, I want a category, I want a brand. This is all required. As I do that, I'm just going to construct that deal entity that we just saw, that object in my application. And then I'm going to call this create deal method, get the result there. If there's an error, I'll throw that error back. Otherwise, I'll just say, we created this. So let's take a look at that data function. So here's that create deal. I'm going to pass in a deal, and all I'm going to do is call DynamoDB put item. I'm going to serialize that deal to an item, because remember that item knows how to go into DynamoDB format. And then I'm going to have this condition on it where I'm going to say attribute not exist PK, because I want to make sure that this deal doesn't already exist in our database, because I might overwrite one. If that error comes back, then I'd say I couldn't create a deal, but otherwise I'm just going to return that deal to the user. All right, and then just to make sure that this code actually works, we're going to actually execute it. So we've got our base URL. This is the /deals route. I've got my body here. Notice that it has the title, the link, the price, the category, the brand, everything that I created there. So let's send that in here. And there we go. I have my deal in there. Let's say I want to add just another one. Let's do our Air Force 2s again. Again, they're just slightly more expensive. So let's send that up there just to get a few deals in our application. So we can see that works. We're getting our deals back. All right, so we've modeled this part out, and what we've solved so far with this truncated timestamp is the size of a partition, where we want to get some ordering across all our deals, but we don't want to put them all in one partition because that partition can get huge. But we have a second problem, and that's the speed that we're going to be hitting certain partitions in our table, as everyone's going to be fetching the latest deals. So let's talk about how we can cache some of these latest deals every time a deal comes in, because really those 25, 50, 100 most recent deals are really what's going to get caught a lot as people go to the home page. So one thing you could do here is this particular architecture, where on the top there, when this internal editor adds a new deal to your application, you have DynamoDB stream set up. It invokes a Lambda function. That function realizes that a new deal has been created and that we want to sort of refresh the latest deal. So what it's going to do is go hit DynamoDB, query, maybe the most 50 or 100 most recent deals that are in our store, and then go put them into Redis. And now when application users come and they say, hey, give me the latest deals, we'll check sort of what deal range they're at. And if they're getting, the most recent 50 or 100, we'll send them straight to Redis. If they get deeper into our catalog, then we can go actually to DynamoDB, where there's less likely to be pressure on that DynamoDB table and on those particular item collections. This adds some complexity here, because now you have not only streams and Lambda, but you also have this different data store. So you can actually take out that Redis data store if you wanted to and do it all in DynamoDB. And what it would look like is a similar pattern here. That internal editor adds a new deal to the application. That puts that deal on the stream, invokes your Lambda function. Your Lambda function realizes that a new deal has come in. What that Lambda function is going to do is go reach out and get 50 to 100 of the most recent deals and write them back into DynamoDB, but in different items that are just serving as a cache. And basically, here's the structure that we're going to have here. These cache items are going to have a primary key where the partition key is deals cache hash, and then the number of that particular cache, and then same thing with the sort key. And then it's going to have a single attribute on it, the deals attribute, which is just going to be a list of those 50 or 100 most recent deals. And what you can do is you can replicate this out as many times as you want. So if you wanted to make 10 or 50 or 100 copies of this data, you can do that. You make 50 or 100 items in DynamoDB. And now when a read comes in, we're going to split that across all those items. So all these users are coming in at the same time. They're hitting your application server saying, give me the latest deals. You can just choose a random number between 1 and whatever the number of items you have. They'll get that, and each one can go to a different item in DynamoDB, which will be stored on a different node, and it'll alleviate some of that read throughput issues you might have if you're trying to do more than 3,000 reads per second on a single item. Now, this isn't required, and this isn't something I actually implemented in the application code, but I'm just giving you a sense of what that could look like. The great thing is you can implement this after the fact. So if you found out that those deals partitions were getting too hot and having trouble reading it, you could add these caches on after the fact to help you spread that out. So let's just take a quick look at our entity chart. We've got one entity in there, that deal entity. The PK is going to be deal hash deal ID, and the SK is going to be deal hash deal ID as well. If you look at that GSI1, then our deal is going to be deals hash and that truncated timestamp, where that timestamp is going to be truncated down to a particular date. And then also that GSI1 SK is going to be deal hash deal ID. So let's just stay on subject here and handle our other two fetch most recent patterns. And let's start with brands first. And again, we have that same pattern of, fetch a brand and the most recent deals for a brand. And the interesting thing there is that's that one-to-many relationship. We saw this in the last chapter where you might want to pre-join that data by putting both that parent entity, that brand, in the same item collection as the deals. But there's a little bit of a tricky problem there with that truncated timestamp versus that pre-join where because we're doing this truncated timestamp, what we're doing is we're taking those deals and we're splitting them across a large number of partitions rather than all in one partition. So then we can't pre-join our data in that same way because we'd have to get that brand in each of those partitions with that truncated timestamp. So instead, we're not going to worry about that. We're just going to use this truncated timestamp pattern for deals and brands as well, and we'll handle that with multiple requests. So if we look at our GSI2 pattern for the deal item, it's going to be very similar to the GSI1. The difference here is we'll also have the brand name in there. So that GSI2 PK will be brand hash, the brand name hash, and then that truncated timestamp. And then that GSI2 SK will be deal hash deal ID. Again, very similar to what we've done already. If we switch that over and do that for category, which is going to be the same pattern as well, we'll do the same thing. We'll do this in GSI3. So the GSI3 PK we'll have here will be category hash category name and then hash truncated timestamp. And then that GSI3 SK will be deal hash deal ID. Now, I want to show you in code what it looks like to query across those different partitions with the truncated timestamp, but I want to model out the parent entities first. So let's move on to that. Let's model the brand entity. And the first access pattern we're going to have with that brand is fetch the brand and the deals for the brand. Now, as we already mentioned, we're not putting the brand in each of those truncated timestamp partitions, so we can just put the brand separately. So we'll just do a very generic pattern for the brand where we'll do brand hash and then the brand name for both the partition key and the sort key. So you can see I've got a few different brands in here. I've got Apple, I've got Amazon, I've got Gucci. So let's walk through the flows here. And first thing I want to do is create a brand. And remember that deal I already created was for Nike, so I'm going to create that brand. So I've got the name Nike here. I've got a logo, and it's going just a post request to this brand's endpoint. Let's send that up, make sure that works. And here we go. We've got this brand that we've added here. Now, if I want to do that get brand, I can do it on the /brands/Nike, which is that brand name. And, this is going to fetch the brand and all the latest deals for that brand. So let's make sure that that's getting what we want. And here we have that brand, we have Nike, and then we have our latest deals. And you can see they're ordered by the most recent because that Air Force 2s, that was the second one we sent up. We've also got the Air Force 1s in there as well. Let's take a look at the code to handle that fetch brand and fetch latest deals for brand. So this is the data access function we have here, get brand and latest deals for brand. First thing I want to point out is I mentioned we're not putting the brand in that same item collection as the deals because they're partitioned across all these truncated timestamps. So what I'm doing here is I'm actually making two calls in parallel. One is going to be to get this brand, and then one is to get all the latest deals for the brand. And again, these are both going to return promises, so I can do them in parallel. It's not like I need to wait on something from the first to get to the second. So after I fire those off, I just wait for those and then return those results. Here's that get brand function, and all that's doing is just doing a get item on that brand using the key. Pretty simple there. The more interesting one is this get latest deals for brand. And what I'm doing is I'm passing in that brand. I'm passing in created at, which is going to be right now, although someone could specify a different one if they wanted to. And I'm saying, I want 25 and then the count, which is the number of times I've gone through this function. And what I'm going to do here, I'm going to run this query against GSI2 and say, hey, I want to get all the ones where GSI2 PK equals the PK that I'm going to generate down here, which is going to be based on this created at timestamp. And again, that's going to include both the brand name and the truncated timestamp that we're looking in. It's going to get that back and push those onto this deals container that I'm creating. And then I look and see, hey, you know, if the length of total deals that I have is still less than my limit, and I've only gone through this particular function fewer than 5 times, then what I'm going to do is I'm just going to recursively call this function. This is that get latest deals for brand. So I'm just calling that again. But what I'm going to do is take off, subtract a date from it. So I'm going to, you know, I didn't get enough deals from today, so I'm going to look back to yesterday. I'm going to, for my limit, I'm going to say how many more deals I need, and I'm also going to increment this counter to say I've been through another time. Going to fetch more deals and concatenate those to my existing deals and then return those. So what it's going to do is, imagine, you know, I only had 4 deals in today's in today's date for Nike. I would get those 4 deals and I would say, okay, I'm actually looking for 24 deals. So let's run through yesterday's and see if I can get some more. If I get, you know, 14 more there, now I'm up to 18 total, and say, hey, can I get 7 more? So I looked at 2 days ago and maybe I get 7 more there and I return those. Now, one thing I do want to do is I have that limit there where I'm only going to go back 5 days, because it's possible a brand doesn't have 25 deals total. And I just keep looping back, you know, till the beginning of time, trying to satisfy this, or until my function timed out. I don't want to do that. So I'm going to look back up to 5 days, trying to fetch up to 25 items. And that's how I'm handling that, iterating over these different partitions that I have. So that's how we handle that first access pattern of fetching the brand and the latest deals for that brand. You're going to do the same thing for the latest deals overall, where you're going to look back at today's deals. You know, if you don't have enough, then you'll go back to previous days as needed. Second access pattern we have around brands is fetching all brands. And this is usually a pretty tricky access pattern for DynamoDB to handle, of fetching all items of a particular type. But we can check out our use case here and see how we'll handle it. First of all, let's think about how we want to handle that. And in our application, you know, there is that brands tab that's going to take you to just a list of all the brands like this. A couple interesting things to note here is all we need to have is the brand name, just to display that name, and then we can link out to the actual brand page based on that name. So it's easy for us there. We don't need to store a lot of metadata about that brand. Second, we don't have a ton of brands. You know, there's 100, maybe 200 brands in our application. We add, you know, 1 or 2 a week or a month. So it's not a huge amount here. So we're going to actually do something interesting here and just create a brands container object where we have this static item. The partition key is going to be brands, and the sort key is going to be brands as well. And all we have is this set item, this attribute called brands, that just has every single brand that's in our application. So whenever we create a new brand in our application, which is going to be done by an editor in our CMS, it's also going to add it into that brands set on this brands container object. Let's check this out in code, and then we'll give it a test with Postman. We have this create brand function here where we're passing in a brand. As part of that, we're creating this brand container object, and then we're just going to run a transaction with 2 different request items in it. Number 1 is going to be a put, and that's going to be to create that brand. So it's going to turn that brand into an item and make sure that it doesn't exist already by having that condition expression on it. The second thing we're going to do is update that brand container and just make sure we add that brand into that brand set. So we're going to take you know, the brand container's key. We're going to do an update expression that says, hey, there's an attribute called brands. We just want to add this new brand into it. It's going to be this brand name. It's going to be that string set that we're using there. And that's what it's going to do. And so every time we create a brand, it's also going to be updating that brand's container. So let's go back to Postman and try that out. We have this list brand function, which is just going on the brand's path, and it's doing a get. So let's send that up. That's going to go fetch our brand container object and just return the value of that set. So we have Nike in there. If we want to create another brand, let's just try that out here. So in addition to Nike, we also have Adidas. Let's change that accordingly. We'll send that up to create our Adidas brand. It's done. We can actually make 2 requests just to make sure. Look, a brand with that name already exists, so we're making sure that we have uniqueness there. Then if we go back to list brands, fire that out, now we have both our brands in there. We have Adidas, we have Nike. All right, so that's how you handle that fetch all brands access pattern. Kind of a unique one. It's a little tricky to fetch all entities of a particular type, but there are some strategies to do it, and that's one of them. A couple more access patterns we have around brands, and remember that users can both like and watch brands. So let's model that out. When we're doing that like brand, there are a couple things we want to do. Number one, we want to increment the like count on that brand item itself so we can keep track of how many likes a particular brand has without having to go scan all the existing like items. Second, we want to keep a tracking item that just says, hey, this user has liked this brand. So then if they try and like it again, we'll prevent them from doing that just so they don't rack up likes on a particular brand from one user. So what we'll do for that item here, we'll just have the PK will be brand like hash and the brand name and then hash username. So it includes both the brand name and the username in there to make sure that the user hasn't already liked this brand. We'll do the exact same thing for the sort key. The interesting thing about this like brand access pattern is we don't have any access patterns around like fetch likes for brand or fetch likes for user into where we want to see the individual items. So we don't have any grouping into a single partition. So we're spreading this out across a lot of partitions. Now it's a little bit different for the watch brand access pattern because again, we want to do that same sort of tracking where we have the watch count for a brand. We also want to make sure a user isn't watching a brand multiple times and jacking up that count. But then when we're sending messages to all the users that are watching a brand, we want to be able to say, hey, fetch me all the users that are watching this particular brand so that I can send a message to them. So we do need to do some grouping there. So this primary key is going to be a little bit different on this one. What we'll do is we'll have a PK of brand watch hash and then the brand name and then a sort key of user hash username. And this will make sure that all the watchers for a particular brand are in one item collection, one partition, so that we can fetch all those and send messages to them later on. So let's just update our entity chart with what we have here. We've got the brand in there now, and that PK is going to be brand hash brand name, and the sort key is going to be brand hash brand name as well. We've also added this brands container object, was what I'm calling it, but just all the different brands we have all stored on one object. Again, the PK and the SK there is just a static value of brand, so that we can just fetch that, do a key value lookup. If you want to do that caching strategy that we did with the deals cache in the previous example, you could do that as well. Finally, we're adding these new entities in here, the brand like and the brand watch. Those patterns are for the brand like, it's brand like hash and the brand name hash username. Same thing for the sort key. Brand watch would be a little different because we want to be able to look up all the watchers for a particular brand. So you have brand watch hash brand name, and then the sort key is going to be user hash username. So let's move on to the next entity, which is the category entity. And it's going to be pretty similar to the brand entity because we've got a lot of the same access patterns. You want to fetch the category and all the latest deals for the category. That pattern is going to be very similar. One thing that is going to be different is we have this idea of featured deals for a category. We can set the featured deals for a category. So we'll make sure to handle that one as well. First thing we're going to do is just make that category item, and we'll just use basically the same thing we did with the brand where the PK will be category hash and then the category name, same thing with the SK. One thing that is interesting and different about the category is we're going to have this featured deals attribute, which is just going to be a list of all the different deals we're going to have. And if you think about how a deal becomes a featured deal for a category, this is going to happen in our internal CMS where our editors are going to be playing around. They can see all the different deals. They can look up a deal by an ID if they want to, and then they say, okay, in this category, let's set these deals. So we have some flexibility there where we can just, they can sort of drag and drop those different deals and send up that entire payload of the featured deals they want to set for a category in one shot rather than sort of marking a deal as featured or things like that. So we can take advantage of that because it's our internal CMS. So let's see what I mean by that here. Let's imagine we want to set the featured deals for the sports category. Let's go get our deals that we already created for Nike. So we'll go get those. They were returned back to us. We can just copy these right here. Copy. Now I'm going to update this category. This is going to be the sports category here. It's got this featured deals that I need to pass up with it. So I'm just going to paste those in there. And now when I do send, now it updated that category with those deals. It's got the name of sports. It's got the different featured deals. And now if I want to go get that category, get the sports category here, it's got those featured deals in there. So again, it's also got the latest deals as we're saying. So again, featured deals and latest deals, it happens to be the exact same here, but you could have something different. The big idea here is we're using that internal CMS to just send up everything we need, all the different featured deals, things like that, rather than sort of marking a deal as featured. So we can take advantage of that. So that's how we handled that set featured deals for category. Last couple things we want to do with a category is again, handle the like category for a user and watch category for a user, just like we did with brands. The patterns here are going to be the exact same. The PK for that like category will be a category like hash category name hash username, same with the SK. And then for a category watch, we'll have PK of category watch hash category and a sort key of user hash username. So if we go back to our entity chart, fill in a few things here. We've got that category, which is going to be category hash category name for both PK and SK. Then we added these two new entities in here, category like, category watch. Same sorts of pattern we did with the brand like and brand watch. All right, so the last thing I want to handle around deals and deals specifically are what I call these special pages, where we've gone through a few different types of pages like the brands page and the category page that are specific to a particular brand or a particular category. But we also have some more generic pages that aren't more specialized into a brand or category. One example here is that front page. So here's our front page of our app, and it's got the latest deals at the bottom. It's got the categories, but it's also got some changing type data at the top with that featured deals, where we need to store featured deals just like we did with categories. We have a similar thing with that editor's choice page, where editors are going to pick maybe 20 of their favorite deals and put them on there. And where do we store that data? We're going to combine a couple strategies we've already used elsewhere. Number one, we just covered in that categories page how we're storing featured deals just on that category itself as an array, where we're just duplicating that information about those deals that are being set by the editors in our CMS, duplicating that into that attribute rather than sort of marking a deal as featured and trying to make the right item collection there. So we can use that. We also saw with a brands container how we used, I sometimes call it a singleton item, where usually, with your partition key or your sort key, you include some specialized parameter in there like the brand name. But here, it's just a static value, brands, and it's just storing all that meta information here. We can do the exact same thing with our pages. And what we'll do is we'll create two new item types here. One is for the front page, and the partition key is going to be front page, and the sort key is going to be front page. One is for editor's choice, and the PK will be editor's choice, SK will be editor's choice. And you can see it's just got a single attribute there, and that's that array of featured deals, and that'll just be set by the editors in our CMS. They'll just handle that directly in a web request, and all we're doing is basically, caching that information about the front page, about the editor's choice on that sort of singleton item. Because this is a newer concept, let's take a look at that in code. So here's my entities module for different kinds of pages. And I just have this base class page that just takes in featured deals as an array. And that to item is just going to add, the type, and it's going to add this featured deals where it's going to stringify that featured deal. And then I have two implementations of that. One is the front page that extends that page. And again, it just sets the key to that static value of front page. Same thing with editor's choice here. It's going to just set it to front page like you see there. Let's try executing this just to make sure it works. So I'll create a new deal just to get away from our previous two. So we've got a cruise here. This is going to be a travel deal, brand of princess. Got that deal. If I go copy, let's see, let me copy and paste this one right here. Copy, go to update the front page. I've already got my Air Force Ones in there as well, but let's put this guy in there, send that one up. Okay, so we updated that front page. Now if we run that get front page, we're doing get just on that / front page. It's going to go there. It's going to get our featured deals there, as well as all the deals sorted by most recent. So that's how that singleton item strategy works. Big thing you got to watch out for is hot partitions, where if everyone's hitting this front page or editor's choice quite a bit, it could overload that partition. But again, as we talked about with the deals cache, you can split that out and copy that exact same data over a number of items that are in different partitions and just sort of randomly query from those. So if we go back to our entity chart here, we're going to add two more entities in here that we didn't have before. We're changing that page into more specific ones. So we have that front page entity that has a PK and an SK of just front page in all caps. Likewise, we have that editor's choice entity, which has the PK and SK of editor's choice in all caps. All right, we're getting close here. We're getting our last couple entities we need to handle. First one we're going to do here is that user entity. So let's take a look at what we have here. We have that fetch user, create user type access patterns. Those ones are pretty similar, so we're not going to cover that too much in depth. The harder access pattern we have is we want to send a new hot deal message to all users in our application. So that's sort of like that brands use case we had before, where we want to fetch all the brands. This time we want to fetch all the users. The problem is we can't use that same sort of singleton item because we have a more unbounded number of users. So hopefully, thousands and tens of thousands or millions of users will sign up. So we can't store all their names in one item. So we're going to need to handle that one a bit differently. Here's what we're going to do here. Here's our table. I've got a deal item up in there at the top for comparison, but then I've also got 3 user items. The primary key pattern I'm going to use there is going to be user hash username for both the partition key and for the sort key. Now, in addition to that, I'm going to have this attribute called user index out there on the right, and I'm only going to include this attribute on user items. It's going to be this user index attribute, and then what I'm going to do is I'm going to create a secondary index that has a primary key of just a simple partition key based on that user index. And because the only items that will have that particular attribute will be user items, this is going to be called a sparse index strategy, where we're intentionally using the sparseness of that index, where it only copies over items that have the elements of your index's primary key. What we're doing here is we're using it to provide a global filter on our table to get just a single type of entity. So in this case, we want to get all users into one easily accessible way. If we look at that index, this is what it's going to look like. We've got all our users in there. And now what we can do is we can run a scan operation just against that index, and it's going to give us only users back. And we don't have to worry about deals or messages or brands or categories or likes or watches or anything else. It's going to be narrowly targeted for that. And so now if we want to handle that send hot new deal message to all users access pattern, this is what we're going to do. It's going to be a 2-part thing. Number 1, we'll scan that user index to get all the users. And then for each user that we find in that index, we'll send them a hot new deal message. Now, we'll look at the implementation of that in just a bit, but first we got to actually create our message entity before we do that. So first of all, let's finish off this user item here. Let's go to our entity chart. For our base table, the PK is going to be user hash username. The SK is going to be user hash username as well. We also have this new user index, secondary index that we're doing. The user is going to have that user hash username in there. No other entity type is going to be in this index because we want to be narrowly focused on just our users in this secondary index. All right, last entity we're going to handle here, last couple access patterns. This is the message entity. And just to remember what we're looking at here, a user can go in and check their inbox. So they're going to have their inbox of these different deals they've gotten alerted to, and they can view it as all messages or only the unread messages. So we have those 2 different access patterns around fetching. Get all the messages, get the unread messages. Now, we'll need to decide if we want to handle that get unread messages access pattern with a secondary index for very targeted queries, or whether we want to use something like a filter expression or client-side filtering to handle that. But with the get all messages, let's do that first. And what we'll do here is we'll have, for all of our messages, this is the PK and SK pattern we'll use. We'll do messages hash username so that all the messages for a particular user will be in a single partition. Then that sort key will be message hash message ID. That message ID, again, like we've been doing for all these other ones, we'll use that KSU ID, which gives us some randomness, but also gives us chronological ordering on that particular ID. Now, moving from messages to unread messages, I prefer to model that into a secondary index if you can, because if you're going to be doing some heavy filtering, I think it's almost always better to do it in an index rather than doing it after the fact, because you're just going to be burning read units. So let's set up a global secondary index, and we'll be using a sparse index pattern. But what we're going to do a little different here. We're filtering within a particular entity type. So what we're going to do on our message is we're going to add this GSI1 PK and GSI1 SK. It's going to be the exact same pattern as our actual primary key, but we're only going to include these attributes if that message is unread. So once that message is read, we're going to delete these attributes off there. It's going to get removed from that secondary index. And now when we query that secondary index, we'll get just the unread messages. We won't get the read messages. All right, so let's take a look at our table with some messages in it. Here we've got 4 different messages. 3 of them came to me, Alex Debris. 1 came to Jeff Bezos. One thing I want you to look at over on the right there, we've got that unread column, that unread attribute saying, is it unread, true or false? Those bottom 3 messages, those are all unread, so they have that GSI1 PK and GSI1 SK value on it. That top one that has been read, that doesn't have those values on it. So then if we go look at our secondary index, it flips like this. Again, it's partitioned by the username. So there's Alex Debris, there's Jeff Bezos, but now Alex only has 2 messages. Jeff still has 1. That red message from Alex Debris has been removed from the table. All right, so those are our 2 read-based access patterns for the message entity. I want to go back to that one access pattern we talked about during users about sending this hot new deal message to all users. Let's see how we handle that. All right, so first thing we need to do is create a users because we haven't done any of that yet. So we're posting to this users path. I'm just giving a username and a name. Let's create that user. And there we go, that user's created. Second thing we want to do is send a hot deal to all the users. So let's get an existing deal ID. We'll just grab that one. And then we've got this send hot deal to users, to all users endpoint. Again, this is going to be hit within our internal application, our CMS. Some editor will create a subject, create a message, and then also input the deal ID there. So we'll paste that in. That's going to get posted to this hot deal blast. And what that's going to do, again, is going to run, it's going to scan all the users, and then for each user in there, it's going to send out this message. So let's give that a shot. Send that. And then it returned with a list of users that it sent it to. Now, in reality, I probably wouldn't do this in sort of a synchronous request response HTTP request because you likely have a lot of users. So you'd probably just post this message into an SQS or something like that where it would trigger off some processing. But I just wanted to get some synchronicity here to get a sense of what's going on. Now that we've done that, so what this should have done is sent that user to Alex Debris. Let's go give that. Let's go check Alex's user message and make sure that got sent. So here I'm doing a get on users Alex Debris messages. So let's send that in there. And there we go. We've got one message there. This message, that deal we sent up, hot new deal from Nike. Check out these new Air Force Ones. Here's the deal ID. And it's also marked as unread, just like we want. So again, let's just do that again. Let's create another user. Let's do Alex Debris 2. This is imposter. So we have this second user here. Let's send a new hot deal message. So let's do, this is a hot second deal from Nike. We're going to do that here. Again, this time it's showing two users that it's getting. It's getting Alex Debris and Alex Debris 2. If we go to those user messages again for Alex Debris, we'll see that he has both of those messages in there. They're both still unread. If we go look at Alex Debris 2, Alex has just that second message because Alex Debris 2 wasn't around when that first message was sent. So just got that first one in there. All right, so let's take a look at the code to implement that. In our data layer, we have this send hot deal to all users there. It's going to take in that subject, message, deal ID that we sent in our request. And again, it's going to be doing two things. First of all, it's going to be running a scan. So here we're setting up that the scan parameters. It's doing that on that user index. And it's also setting up this exclusive start key where if we need to paginate over that, that's what's going to happen here. Then we'll enter this while loop, and if there's an exclusive start key, we'll add that in there. We'll execute this scan, and then for all the items that we get in there, we're going to make a batch of user items and then send the hot deal to the users for all the items in that batch. And we'll get down there in a second. After we get through all those items, then we'll loop through again. We'll see if there's a last evaluated key returned from our scan result. If so, we'll set that as the exclusive start key and it'll run again. If not, we'll break out of that loop. We'll know that we've hit all our users and our processing is done. So now let's go down to that send hot deal to users. Again, we're sending in a batch of users with that subject message and deal ID. What we're going to do is we're going to make a batch of request items, and this is just going to be in the format that's expected by that batch write item request. So it needs a put request and it needs the item that you're going to put in there. Now, the thing about that batch write item is it only does 25 items at a time. You can't just give it 100 or 1,000 or 1,000,000, whatever you want to do there. So we're going to split it up into batches and just run through those batches and call this process batch thing. Now, one thing it can do is part of the batch can fail. So if we have some unprocessed items from a particular batch, we'll retry those up to 5 times before we'd finally just give up on them. So we'll try running those 5 times. But then if you go down and look at this process batch logic, that's where we're actually doing the batch write item. We're seeing if we have any unprocessed results and sending those back. So again, this is what's happening there. Number one, we're scanning that table or scanning that user index. For all the users that we get, we're going to run off and say, hey, send them a message. We're going to do that in batch. So we're not calling an individual put item for each message that we're sending. So as we're doing that batching, we're breaking it up into those batches of 25 and handling any unprocessed items. All right, so some of our access patterns are, fetching all the messages for a user, but also there's the access pattern of just fetching the unread messages for a user. So let's check that out. First of all, we're going to go back to our get user messages endpoint, and we're just going to add some parameters here to say unread is true. We want to only get the unread messages. So we'll send that up. And again, we get both our messages back because both of them are unread. So let's go ahead and mark one of them as read. I'm going to copy this message ID here and go to this mark message as read endpoint. And what I have here, The path here is just going to be post users, Alex Debris, messages, and then the message ID there. So I send that one up. It says okay, just to acknowledge that it received it. So now let's go back here and get those user messages. Again, we got the unread equals true, so I should get just one message in this one. So now I just have that one message that's still unread. Now if I take off that parameter again, now I want to get all my messages. I send that. I still have both my messages, but we have this first message. It's now marked as read by saying unread false. So if I do that unread filter, it's not going to return there. So let's take a look at that implementation in code. First, the mark message read function that we have here. We're going to pass in a message, and what we're going to do is we're going to run an update item operation in DynamoDB using that message as the key. Make sure that that message exists, because we're not going to be manipulating a message that doesn't exist. If it does, what we're going to do is we're going to change that status of unread to false, because now it is read. And then we're also going to remove those two GSI1 values, the GSI1 PK and GSI1 SK, because we want to make sure that it's no longer included in that secondary index when we go fetch all the unread messages. Now, if we go look at the get messages for a user, we're going to pass that in. We're going to be passing in this unread property, which is either true or false, indicating whether we want to get just the unread messages. And what we're going to do here is we're going to set up our basic parameters to make that request. And then we're going to say, hey, is unread true? And if it is, then we're also going to add this index name parameter, because the query is going to be almost exactly the same between these two. The only difference is we're going to put in that index name. We're going to say, hey, PK is actually GSI1 PK, but other than that, they're the exact same. Then we'll run that query. It's going to either hit that base table if it wants to get all messages, or it's going to hit that GSI1 sparse index if it gets just the unread messages, and it's going to return those to us. All right, so that's how we handle that. Send hot new deal message to all users. We also saw how you can get all messages for a user or just the unread messages. Last thing we want to handle here, how do we send these new brand deals to brand watchers and new category deal to category watchers? Let's check that out. All right, so let's get started with brands. Let's do some liking and watching here. First of all, we're going to like brand for a user. So this is at the /brand/Nike/like/Alex Debris endpoint. So it's saying which brand, Nike, and which user is doing the liking. So I'm going to send that up there, make that request. It goes message okay. And now if I try and do it again, user has already liked this brand, because we want to make sure they don't do it multiple times. If we go back and get that Nike brand, let's take a look at it now. You can see this brand now has a like count. We've got one user that has liked this brand, which is great. We can try that again. Let's do it with our second user, Alex Debris 2. Send that up again, message okay. We can try it again. Users already liked this one. But now if we do that get brand, now there are two users that have liked it. Okay, so that's how we implement that. Let's do the same thing for watches here. And we're going to have Alex Debris watch the Nike brand. That's going to look okay. If we do that brand here, there we go. So now the watch count is 1. So now 2 users have liked Nike, 1 user has watched Nike. Now let's take a look at the implementation in code here. So what we have is this watch brand for user function. It's going to be the same whether you're liking or watching, and whether it's a brand or a category. It's the exact same thing. But what we're going to do is we're going to do a transaction. So we have this transact items that we're creating here, and we're actually putting 3 items into this transaction. Number 1, we're doing a put on that brand watch. We're creating that brand watch item to make sure that it exists, and we're having that condition to make sure that it doesn't previously exist, which means that this user has already watched this brand. At the same time, we're going to update the actual brand item itself. First, we want to make sure that item exists, because we want to make sure this is an existing brand. If that happens, then we're going to increment this watch count, and we're going to set it equal to the existing watch count plus this increment, which is going to be of 1. So this is how you can increment that up and just keep a count of how many people have watched it. Again, this is going to save us from having to go back to that brand watch and query all of them for a particular brand to see that up-to-date count, because we want to show that on our brand page. We're going to do the same thing with likes. So there's an attribute called likes count. And then also we'll do the same thing with categories as well. Last thing we're going to do this condition check as well, just to make sure the user exists. I don't have any authentication set up on this, so if you had better auth and you had a good sense the user existed just by virtue of the token or whatever they sent up, then you might not need this one, but I have it in mine. All right, so now that we know how these like and watch count works, let's get into that very last thing we want, where every time a new deal is created, we want to send messages to all the people watching that brand and all the people watching that category. So let's see, Alex Debris is already watching the Nike brand. Let's keep that there. And then for the sports category, let's add the other user, Alex Debris 2 there, just to be able to show what this looks like. So message is okay. So now Alex Debris 2 is watching that sports category. All right, so before we do that, we're just going to check messages, and then before we create a deal, just to know what we're looking at here. So here, Alex Debris has 2 different messages. Both of them are sort of the hot new deal ones that we've created earlier. Likewise, if we do Alex Debris 2, Alex Debris 2 has just the 1 message there. So now let's create this new deal, and this is going to be a new deal entirely. This is going to be Nike. The category is sports, and the title is Just Do It T-shirt. So remember that Alex Debris 2 is watching the sports category. Alex Debris is watching the brand Nike category. So let's send that up there. We create that brand. That's been created now. So let's go back here and let's look at Alex Debris 2's messages and see what they have there. Now you can see, look at this. A new deal just arrived in sports. Check out this hot new deal for sports. Just Do It T-shirt. So that happened all automatically. We'll take a look at what that looks like down there. If we want to take a look at Alex Debris' messages, let's get those. Likewise, he got a new deal that just arrived in Nike. So he's not watching sports, but he is watching Nike. So check out this hot new deal for Nike. It's the Just Do It T-shirt. So again, both of these happened. Let's take a look at what that looked like. So this is going to be our first time using DynamoDB streams, but this is really cool. You can get some of that reactivity, event streaming type stuff. So we have a Lambda function here that's handling this. It's going to get this event with some different records that indicate different write operations that have happened on that DynamoDB table. What we're going to do is filter that and make sure it's an insert, which means it's a brand new item being put in there, and then also that the new image that's being in there, the type of that is deal. So we're making sure that this is a deal that has just been created in our DynamoDB table, which means it won't operate on users, or it won't operate when you update a deal or anything like that. So we have each of those. Then what we're going to do is for each new deal item we have, we're going to notify the brand watchers and notify the category watchers. So let's look at one of those. We have this notify brand watchers. This is that data layer. So we have the notify brand watchers function there. It's going to take in a deal. And what it's going to do is going to be very similar to when we were doing the hot new deal to all our users. It's going to query that particular partition for all the brand watchers. And as it goes over those, it's going to send that new brand deal to the users. So again, just like we were doing with that hot new deal where we were scanning that user index to find all the users, here we're querying the brand watch partition to find all the watchers for a particular brand, and then we're going to send them this message. We're doing the exact same thing with category watchers as well. Again, this is all happening asynchronously, reactively, using that DynamoDB streams, which is really cool. All right, so let's get back to our slides. We finished up those how to send new messages to brand watchers and category watchers. So let's look at our entity chart and how it was updated by that message. Again, we got that message at the bottom. The PK is messages hash username. The SK is going to be message hash message ID. Then if you look at the GSI1, for unread messages only, we're going to duplicate those properties over. So we'll have GSI1 PK, GSI1 SK with the same properties as the PK and SK on the base table, but only if it's an unread message. So that way we can easily filter down to unread messages. All right, so if you're still with me, we made it. This is the most complicated example we've had so far. It had 22 different access patterns, a ton of different entities, a ton of cool stuff. Let's just review what we did here. First of all, our table is going to use that composite primary key with PK and SK, very generic properties like we always do. We have 4 secondary indexes. 3 of them are just generic GSIs, GSI 1, 2, and 3 with a generic composite primary key of PK and SK. Finally, we also have that user index. That's a sparse index. It has a partition key of user index. The only property that's going to be projected into there is going to be that user entity. If we look at our entity chart here, I'm not going to walk through each of those because you can if you want to, but we've got 8 different entities here. These are the big core ones. We also have the brand like, brand watch, category like, category watch here as well. So 12 different types of things we're representing here. Finally, if you look at our GSI1 PK, that's mostly used for the deals and get the latest deals, but we also have that unread messages access pattern if we need to. GSI2, we're handling with the latest deals for a particular brand, and then GSI3, we're handling with the latest deals for a particular category. Again, all of those are using that truncated timestamp strategy that we talked about early on. Finally, we have that user index where it's just going to be the user that has that user hash username attribute, going to project all those users into that index so we can scan those quickly and send messages to all the users as we need them. All right, let's review our access patterns real quick. I'm not going to go in depth on these because we just talked about them, but just a reminder, those first three are going to be actually creating those entities. That's all going to happen in the internal CMS. The really interesting thing that's going to happen there is probably on that brand entity where you're also adding it to that brand's container object, that singleton item. In addition to that, we have a few access patterns around setting the featured deals for a few different types of entities, the front page, different categories, editor's choice page. Interesting thing here, that's going to happen in the internal CMS. So that gives us some flexibility where we can require that the whole payload of all the featured deals just gets sent up there, and we don't have to worry about marking particular deals to be included into this item collection. Next couple access patterns we have are those read-based patterns, especially around fetching the latest deals in either the front page or a category or a brand or things like that. The biggest interesting thing there, I think, is both for the front page, the category, and the brands is just how we fetch those latest deals, where we're going to query across those truncated timestamp partitions. We'll look at a few of them until we get 25 items and then return those. So look at the code if you're interested in that one. We also have, the fetch all brands access pattern, which you're just going to do a get item on that brand's container, and then the fetch deal, which will also be a get item on that deal with a deal ID. Finally, we have these access patterns around users and interactions with different items. So you have that create user access pattern, and then you also have like brand, like category, watch category. And the big thing you want to think about there is including it in transactions to where you're incrementing the reference count on either the brand or that category for either the likes or the watches, but also making sure that the user hasn't previously liked or watching that by creating this tracking item for them. Finally, the last set of access patterns we have are all around messaging, right? So we have the view messages for a user, view unread messages for a user. The only difference there is, are you hitting the main table or are you hitting the GSI one that only has the unread messages in it? And then we have, hey, sending some messages to our users. How do we do that? So we have the one that goes out to all users whenever there's a new hot deal. That's going to scan that user index, find all the users, and then for each user that it finds, create a message to send to them. We also have those reactive access patterns around new brand deal and new category deal to the watchers. They'll just listen on a DynamoDB stream. When they get a new deal that comes in, they'll find all the watchers for that brand and for that category and send them messages. And we saw how DynamoDB streams power some pretty interesting workflows there. All right, that concludes the big time deals example. This is a lot of fun, a lot of access patterns, a lot of entities. The next one is about GitHub metadata backend, which I think is fun because it's something we're all familiar with as developers, how to use GitHub, but it also has a lot of complex access patterns, a lot of interesting requirements. So go check that one out.